Look at this object. It sits right in front of you in plain light, and yet something is deeply wrong with it. You cannot see its shape. You cannot tell if it is flat or round or deep. It does not look like a thing at all. It looks like a hole, a window into pure nothingness cut into the middle of the world. This is one of the darkest materials ever created by human hands. And what it does to light will change how you see darkness itself. To understand it, you first have to understand what black really is. Everything you see because of light. When light strikes an object, some of it bounces back into your eyes, and that reflected light is what lets you see color and shape and form. A red apple reflects red light. A white wall reflects nearly all of it. And black? Black is what you see when an object reflects almost nothing at all. The darker something is, the more light it is swallowing. Now, even the things you think of as truly black are not as dark as they seem. A lump of coal, a patch of shadow, the night sky, all of them still reflect a small amount of light back to you, which is why you can still make out their shape. But this material is different. It absorbs more than 99.9% of all the light that touches it. Almost nothing comes back. It is, very nearly, as black can possibly be. And the effect of that is deeply strange. Take an object with bumps and folds and curves. Coat it in this material, and something impossible happens. All of its features simply vanish. The ridges, the shadows, the edges, everything your brain uses to see a shape, all of it disappears. What is left looks completely, perfectly flat. A shape you could hold in your hand, reduced to a silhouette of pure black. A two-dimensional void floating in a three-dimensional world. The most famous demonstration is almost impossible to believe. Take a sheet of shining metal foil and crush it in your fist, full of sharp creases and crumpled peaks and valleys, catching the light from every angle. Now coat one half of it in this material. Instantly, that half looks as if it has been erased. The crumples are gone. The texture is gone. It becomes a smooth, flat, bottomless black, as though a piece of the world has simply been deleted. So why does this happen? Why does your mind fail so completely? Because your eyes have only one way to understand a shape, the pattern of light and shadow bouncing off its surface. But here, no light is bouncing off at all. There are no highlights, no shadows, no reflections. Your brain reaches out for the visual clues it needs and finds absolutely nothing. And so, faced with nothing, it simply shows you a hole. So what is this impossible material actually made of? The answer is astonishing. Its surface is not smooth at all. Instead, it is covered in a dense forest of microscopic tubes, countless billions of them, each one far, far thinner than a single human hair. They stand upright, packed tightly together, like the trees of an unimaginably tiny forest. And it is this hidden forest, invisible to the eye, that swallows the light. Here is how it works. When a ray of light arrives, it slips down into the gaps between these tiny tubes, and once it is inside, it becomes trapped. It bounces from tube to tube, over and over, deeper and deeper into the forest. And each time it bounces, a little more of it is absorbed. It almost never finds its way back out. The light goes in, and it simply never returns, quietly turned into the faintest whisper of heat. And the scale of it is difficult to imagine. Within a patch of this material, no bigger than your fingertip, there are more of these tiny tubes than there are people on the entire planet. An entire microscopic world, standing on a surface you could cover with your thumb. Each tube a perfect little light trap, all of them working together to erase the light completely. To stand before it in person is an unsettling experience. People describe it as looking into a hole with no bottom. Your eyes keep trying to focus on it and keep failing because there is nothing there to focus on. It feels less like a color and more like an absence, a piece of empty space somehow brought into the room. For the first time, you are not looking at darkness. You are looking into it. And the strangest part, we keep making it darker. Since this material was first created, scientists have engineered even blacker blacks, materials that absorb not 99.9, but 99.995% of all light. Each new record swallows just a little more, creeping ever closer to a perfect, absolute black, a darkness that reflects nothing at all. But here is something that might surprise you. This extraordinary material was not made for art or for show. It was made for science. Because in the most sensitive instruments we build, there is a hidden enemy: stray light. Tiny, unwanted reflections that bounce around inside a camera or a telescope, blurring the very things we are trying to see. And to catch the faintest signals in the universe, we first need to master the dark. Imagine trying to photograph a single, faint star while stray light ricochets around inside your instrument like a trapped firefly. That scattered light drowns out the delicate signal you are hunting for. But line the inside of that instrument with the blackest black, and the stray light vanishes, absorbed, silenced. Suddenly, the faintest whisper of light from across the cosmos can be seen clearly against a background of perfect black. This is why the darkest materials are heading into space. Coated onto the inside of telescopes and sensors, they help our machines peer deeper into the universe than ever before, hunting for distant planets, faint galaxies, and the faded light of the earliest stars. In the endless dark of space, we are using an even deeper darkness as a tool to help us see the light. This obsession with darkness has even led to conflict. When the blackest black was first created, the right to use it was locked away, handed to a single artist for art. The rest of the world was shut out. It sparked outrage and a strange, colorful feud as others raced to make their own blacks, free for anyone to use. A fight over the color of nothing. But beyond the arguments, the uses of these materials are only growing. The same power that swallows light can be turned to many tasks. It can help hide objects from certain kinds of detection. It can sharpen the vision of our most delicate instruments. It can even help capture the sun's energy more completely by refusing to let a single ray escape. Darkness, it turns out, is not empty. It is useful. But perhaps the most profound thing about it is not what it does, but what it shows us. For all of history, we have imagined nothing, pure emptiness, the void, absolute dark. But we could never truly see it. Now for the first time we can. In this material, we have built ourselves a window, a small, perfect piece of visible nothingness that we can hold in our hands and stare into. And still, the pursuit goes on. With every passing year, we edge a fraction closer to a perfect, flawless black, a surface that would reflect not a single particle of light. We may never quite reach it. There may always be the faintest trace, the tiniest whisper of light escaping back out. But we are close, astonishingly close, to creating true, absolute darkness. So the next time you think you have seen something truly black, a shadow, a night sky, the depths of a cave, remember that all of it is still glowing, ever so faintly, with reflected light. Real darkness, perfect, total, absolute darkness, is far stranger and far rarer than you ever imagine. We have chased it into the laboratory. We have very nearly caught it. And we have learned something remarkable along the way. Sometimes To truly understand the light, you first have to master the dark.